Hello students, in today's class we shall discuss about the law of multiple proportions, and in our previous class we discussed the law of conservation of mass and law of definite proportions. So if you don't watch those videos, please do watch those videos and come to this video. Now let's start the law of multiple proportions. This law was proposed by Dalton, and this law says that if two elements combine to form more than one compound, then the mass of one element that combines with fixed mass of other element are in ratio of simple whole numbers. So if you understand this definition perfectly, we can solve the questions based on the law of multiple proportions very easily, because questions usually connected to the only definition part in this particular law of definite proportions. Let us see what this meaning of the definition here. So they said if two elements. So let us take the two elements, hydrogen and oxygen, combine to form more than one compound. So they combine with each other and forming the more than one compound, H2O and H2O2. Then the mass of one element, so you have to select a mass of any one element that combines with the fixed mass of the other element. That means one of the element mass has to be fixed. Then other element mass is not fixed. So the element whose mass is not fixed, when it combines with the fixed mass of the other element, that non-fixed mass element, its mass is always present in the ratio of the simple whole numbers. So let's discuss this example H2O and H2O2. I'll write down this one here, H2O and H2O2. So let us try to solve this question in the two methods. So in the method 1, let us see the mass of these hydrogen and oxygen, both of these compounds. In H2O, 2 grams of hydrogen combines with the 16 grams of the oxygen. So ratio is 1:8. In this case, 2 grams of hydrogen combines with the 32 grams of oxygen. So here you can take the 1:16. This simplification is not required because starting step itself only hydrogen mass is fixed. 2 grams, 2 grams. Then whose mass is not fixed? Oxygen mass is not fixed. So we have to take the oxygen element, because here according to definition, the element which combines with the fixed mass of the other element means the element whose mass is not fixed, that element ratios we have to see. See, in this case hydrogen mass is fixed, so that I am not taking the hydrogen. Then I have to take the mass of the oxygen. What is the mass of the oxygen? First compound 16. And second compound is 32. Then it is simply simple whole number ratio 1:2. Let us take the method 2. In this method, the question arises, why we need to fix the only hydrogen, why not oxygen? In this case, now let us try to fix the mass of the oxygen fixed, hydrogen is non-fixed. So here, as usually 2:16 grams is present, 2:32 grams is present. So I am fixing the mass of the oxygen now. Now I want to take the mass of the oxygen only 16 grams. So with the 16 grams of the oxygen, how much mass of the hydrogen is combining? 2 grams. Here 32 grams is it. Then you simplify this one. It is 1:16. In this case, 16 grams combines with 1 gram. So whose mass is fixed now? Oxygen mass is fixed. Whose mass is not fixed? Hydrogen mass is not fixed. You take the hydrogen mass ratios. So that is 2:1. It is also best the simple whole number ratio. So like this, we have to understand the law of definite proportions. Let us try to see other examples of the law of that is multiple proportions. So other examples. And how to understand these examples also we shall discuss now. Example 2. That is oxides of nitrogen. You take N2O, NO, NO2, N2O3, N2O5, etc. Example 3. Oxides of carbon. CO, CO2. Example 4. Oxides of phosphorus. P2O3, P2O6. Example 5. P2O5. Oxides of chlorine. So let us take the Cl2O, ClO, Cl2O3, Cl2O7. So still now we have taken only oxides. Let us take the other elements also. Hydrides of nitrogen. Hydrides of nitrogen, you can take N3H, NH3, hydrogen, N2H4, etc. Next example, chlorides of phosphorus. PCl3, PCl5. Next example, oxides of sulfur. This is SO2, SO3. Then how to understand these examples, whether these are following the law of multiple proportions or not. We are not necessary to calculate fixed mass and all this. Directly by definition, if you apply there, you will get the answer. They said, select the 2 elements. So in all these compounds, only 2 elements are present. See, 2 elements, nitrogen oxygen, carbon oxygen, phosphorus oxygen, chlorine oxygen, nitrogen hydrogen, phosphorus chlorine, sulfur oxygen. Only 2 elements are present. So whatever the number of compounds you are selecting, if they are having 2 elements and these 2 elements only forming the different number of the compounds, obviously they follow this rule. So whatever the number of examples they are giving in the examination, just see the option that is having the 2 elements with the same elements, same 2 elements must be there, but a different number of compounds. They all follow the law of multiple proportions. Now let us see what are the limitations of the law of multiple proportions. So here limitations. Limitations are very less, even though we have to discuss that less limitations. That is, we know that carbon has catenation property. Catenation property means chain tending form nature. So it forms the number of compounds because of its highest catenation capacity. So in that compounds, can we follow the law of multiple proportions or not? Usually it will not follow. The reason here is when carbon is having the catenation property and forming the various number of the compounds, this law of multiple proportions cannot be applied there. Let us see some examples here. Butane, molecular formula C4H10. Pentane, C5H12. Hexane, C6H14. So if we calculate the mass ratio of these elements, let us fix the mass of the carbon. I am fixing the mass of the carbon as 12 grams. Means in every case, with 12 grams of carbon, how much mass of the hydrogen is going to combine? See here, 4 into 12 grams. 48 grams of carbon combines with the 10 grams of hydrogen. With 12 grams of carbon, how much mass of the hydrogen is combined? That is 2.5 grams. In this case, it is 2.4 grams. In this case, it is 2.33 grams. And if you take this non-fixed element mass ratios, they are not simple whole number ratios. That is the reason why this law of multiple proportions cannot be applied where this type of the chain compounds are going to form. In some cases, boron compounds also do not follow the law of multiple proportions, and silicon also having the little tendency of the forming the chain tendency capacity, catenation property. That's why silicon also do not form some compounds of the silicon do not follow the law of multiple proportions. Let us see some questions that how the question shall be asked in the based on the law of multiple proportions. So the question here is, a metal M forms two oxides. These oxides are oxide A, oxide B. Percentage of oxygen in oxide A is 27.6%. In oxide B is 30% of oxygen is present. And the formula of the oxide A is given as M3O4, and they are asking us what would be the formula of the metallic oxide of B compound. So let us try to solve this question. So we have to keep one point in mind that whenever we want to solve this type of the questions, percentage of one element is given means percentage of the other element is also obviously known when two elements are present. When molecular formula of the one element is given, other compound molecular formula has to be calculated. So in this case, always we have to follow the moles ratio. Let us see how to solve this question now. So solution. So let us take the oxide A. So in case of oxide A, let the total mass of compound or oxide is equals to 100 grams I am considering. Then mass of the oxygen is equals to 27.6 grams. And mass of the metal is equals to 100 minus 27.6. It gives approximately 72.4 grams. We don't know the atomic mass of the metal. Let atomic mass of the metal is X grams. Whereas atomic mass of the oxygen we know already, that is 16 grams. Now let's try to solve this one. From the formula, so here, from the formula, it is clearly known that 3 moles of metal and 4 moles of oxygen is present. So here, number of moles of metal by number of moles of oxygen that we try to equalize it. Number of moles of the metal formula is weight of the metal divided by atomic weight of the metal whole divided by weight of oxygen divided by atomic weight of the oxygen. Then moles of the metal and oxygen given in the formula as 3 and 4. So number of moles of the metal 3, number of moles of the oxygen equals to 4. Then atomic weight of the metal, weight of the metal is given as 72.4 grams. So that 72.4 grams divided by X, and here it is weight of the oxygen 27.6 grams divided by 16. So let us try to simplify this. 3/4 is equals to 72.4 by X into 16 by 27.6 grams. So X equals to 72.4 into 16 divided by 27.6 into, here 3/4 becomes 4 by 3. So this value is approximately equals to 55.96 grams. This is atomic mass of the metal. So now let us take the oxide B. So in B oxide also same formula we use it again. Number of moles of the metal by number of moles of the oxygen equals to weight of metal divided by atomic weight of the metal whole divided by weight of the oxygen divided by atomic weight of the oxygen. So this ratio we have to find out now. Number of moles of the metal by number of moles of the oxygen equals to, so weight of the metal in this particular second question for this particular formula. So here 30% of the oxygen is present, means 30 grams of the oxygen. So 70 grams of the metal is present out of 100 grams. Then let us take these masses there. So weight of the metal is given as 70 divided by atomic mass, we calculate it. That is 55.96 grams whole divided by weight of the oxygen, it is 30 grams divided by atomic mass of the oxygen is 16. So moles ratio is equals to, this value is 1.25, this value is equals 1.875, it goes 2/3. So that the formula is, means metal into metal and oxygen ratio is 2:3. So that formula is M2O3. So like this we can solve this question. Let us try to see the another question. So second question. In this question, they are given the various oxides of the manganese. So manganese and oxygen are forming 3 oxides. They are MnO, MnO2, Mn2O7. And the given information is, in MnO, the mass ratio of the manganese and oxygen is 55:16. Then show that MnO2 and Mn2O7 are following the law of multiple proportions. So let us take out these 2 oxides. So MnO2 and Mn2O7. See here, 1 manganese combines with 2 oxygens. Here 2 manganese combines with the 7 oxygens. So even if you take the masses or the number of elements, there is no difference. So here I am considering the element here. In the case of the manganese, I am considering as an element. And for oxygen, I will take the mass. So here 1 manganese combines with 2 oxygens. 2 oxygens mass is 32. Here 2 manganese combines with 7 oxygens, 7 into 16. Then 2 combines with 7 into 16 grams of the oxygen. Then 1 manganese can combine with the how many grams of the oxygen? Obviously half of that, 7 into 8 grams. So now mass or number of mass of the element is fixed because 1 manganese means always it will be 55 as they had given here. Then it is fixed. Whose value is not fixed? Oxygen value is not fixed. So we shall take the oxygen value out. So 32 is to 7 into 8. It goes 4 times. 4 is to 7. It is a simple whole number ratio. So it is also obeying the law of multiple proportions. So I hope you understand this video. If you have any doubt, please do write your doubts to the classroompoint@gmail.com and we shall meet in the next class. Thank you.